8.6 is the last section we do, and we're still talking about vectors. We've added vectors, we've subtracted vectors, we've multiplied by scalars. Now this is the closest thing we get to multiplying two vectors together. It's called the dot product. And notice that I've written my vectors in component form. So I've got A1, that's a horizontal component, A2 is vertical component. Same thing here, but I had to use different variables. So these two vectors are in component form. So their dot product is denoted by this open circle right here. And it's defined by when you multiply the corresponding components. So you're multiplying the two horizontal components and then multiplying the two vertical components and adding them together. Now, make a note of that. This is a number. Not a vector. Right? When we were doing operations with vectors, we were getting other resultant vectors from the operations we were doing. Here, we're actually going to find a number. All right, so that's part of what we need for 8.6, the dot product. The other thing we're going to look at in 8.6, and I'm just giving you all the notes here, and then I'll talk about all of them as we work some examples. If we're going to find the angle between two vectors, we're going to use the dot product. And so to find the angle between two vectors, it's the dot product over the magnitude of one vector times the magnitude of the other vector. Remember that the magnitude is the length. All right, and this actually comes from, notice we've got a cosine. This actually comes from the law of cosines, and I'm not going to prove it or show it to you. Just know that if we're looking for the angle of two vectors, we need our cosine function, and then we need our dot product and our magnitude in order to find those. And then the last thing we're going to do in 8.6 is if the dot product equals 0, that means our vectors are orthogonal. Orthogonal means they're perpendicular. All right, and you'll see that as well as we're working some examples. All right, so let's work some examples here. So I'm given two vectors, and I am asked to find the angle between the two vectors. Let me write that out. Find the angle between two vectors. All right, so to do that, let's write this in component form first. All right, it's in I plus j form, so we want to write this in component form. So it's 1 root 3. And then for v, it's negative root 3 and 1. All right, so let's find the dot product first. So the dot product here, so if you've got problems that are just asking for the dot product, remember what we're doing here. We're taking the corresponding components and multiplying them. So I've got 1 times negative root 3 plus, and then I'm multiplying the vertical components, plus root 3 times 1. All right, so if you're just asked to find the dot product, remember you're getting a number. So I've got 1 times negative root 3, which is negative root 3, plus root 3 times 1 is positive root 3, which means my dot product is 0. All right, so I found the dot product. I've also know that right here, my dot product is 0, which means these two vectors, or let me spell that right, they're orthogonal. Orthogonal. Okay? So there might be questions that ask you just to find the dot product. There might be questions that just ask you if the two vectors are orthogonal. So we found the dot product. We have determined that these two vectors are orthogonal. We'll actually, going all the way with it though, we're going to find the angle between two vectors. Now, the fact that they're orthogonal should already tell you that the angle between these two vectors is 90 degrees, but let's just keep working it out so you'll see it. All right, so if I'm going to find the angle between two vectors, I know that the cosine of theta equals the dot product over the magnitude of u times the magnitude of v. All right, so in this case, I've got the cosine of theta equals 0, and at that point, I really wouldn't have to go any further. Let's go ahead and find the magnitude of u just for practice. Remember to find the length. You're taking the square root of the horizontal component squared plus the vertical component squared. And so this is going to be 1 plus 3 or 2. If I'm looking for magnitude of v, that's going to be the square root of negative 3 of negative root 3 squared plus 1 squared, which is also 2, because we got 3 plus 1, square root of 4 is 2. All right, so we've got 2 times 2, and like we said, that doesn't even matter because we're looking for the cosine of cosine of theta equals 0, which means theta is 90 degrees. All right, let's draw a picture of that so you can see it. So if I were looking at this graph, or the sketch, I should say, of these vectors, right? We've got our first vector is 1 root 3. So there's my vector u. All right, my v vector is negative root 3, 1. So there's v, and you can see by sketching that graph that the angle between these two vectors is 90 degrees. That tells us all kind of things, right? It's orthogonal. It tells us that cosine of theta is 0. It tells us that our dot product is 0. All right, let's do another one. So here we've got my first vector. Let's draw it first. Now you don't have to draw these, but I'm just going to draw it anyway. All right, so we've got negative 6, 6. So over 6, up 6. So there's u. And I'm just approximating. And then we've got v is over 1 down 1. Well, I'm going to guess here that my theta is going to be 180 degrees. Let's confirm that. All right, so let's find the dot product. Our dot product is going to equal negative 6 times 1, which is negative 6. That is not a vector. It's a number. I don't know why I drew that. All right, so we've got negative 6 plus negative 6, which is negative 12. All right, if I'm going to find the magnitude of u, that's going to be negative 6 squared plus 6 squared with the square root of 72. V is going to be 1 squared plus negative 1 squared, which is the square root of 2. Alright, so I know that cosine of theta, using that to find my theta, which I already drew and already know, is going to be the dot product, which is negative 12, over the magnitude of u times the magnitude of v. Alright, so if I were cleaning this up, this would be negative 12 over the square root of 144, because I'll multiply what's underneath the square root there. So that's going to be negative 12 over positive 12, or the cosine of theta equals negative 1. Where does the cosine of theta equal negative 1? Cosine of theta equals negative 1 at 180 degrees. Okay. Let's keep going. One more. Alright, here I'm given that u is in component form 2, 1, and v is in component form 3, negative 2. Alright, so the dot product is going to be 6 plus 1 times negative 2, which is negative 2. So my dot product is 4, means it's not orthogonal. Alright, my magnitude of u is going to be 2 squared, which is 4, plus 1 squared, which is 1, which is the square root of 5. Magnitude of v is going to be 3 squared, which is 9, plus negative 2 squared, which is 4, which is the square root of 13. Alright, so to find the angle between these two vectors, we know that cosine of theta equals that dot product over the product of those magnitudes. So we've got 4 over the square root of 65. Alright, so this isn't going to be a quadrantal angle. This is going to be something that you're going to have to use your calculator for. So we're going to use the inverse cosine and just plug in 4 over the square root of 65, and that's just going to approximate to 60 degrees.